What is work? What is the intersection between science and technology? This is a quick look at the innovations that make life more livable, things that we do with science in order to achieve very human goals. So what is work? This is one of those 4 a.m. note-taking kinds of problems. I was thinking about this and I just couldn't shake it. I was worried about the problem of work and science and technology and how those things intersect in this course. And I was also trying to figure out where this lecture belongs, and I'm not entirely sure, but it needs to be about now between 3 and 4. So the question that you might be having as you're listening to the lectures is, are these breakthroughs and discoveries more technology or more science? What is the dividing line between technology and science? So the ideas for this lecture are sort of scattered all over the place in my past or in my past readings. So I'd like to show you a couple of books you might look at if you are interested in specifically pursuing the development of technology. So if we think about common ideas about science, one of the things that people do sometimes believe or do sometimes say is that science is a pursuit for those who are not dealing with the everyday. They are members of the elite who have time to write or to think or to do math or to make many observations. In this understanding of science, science is more for bird watchers or doodlers, for dreamers and not doers. Someone might make the distinction, if it's tool-assisted but it's practical, it's technology and not science. It is a shovel, not a telescope. I don't happen to ascribe to this idea myself, but you do see it in many scientific texts or many ways that people talk about science and technology. They make a sharp dividing line. I think the two things go together, and I think we will see that more and more as the course unfolds. But you will see that people have understood science as being something that only people with idle time can do. In addition to ideas about who gets to do science and whether or not science is a leisure activity or it's a work activity, another question is about gendering in science. It so happens that in my household, my mother taught biology and my father taught engineering, and my mother was interested in what are the underlying principles. My father was more like, just make it work. And in fact, he did forensic engineering. He studied what broke and why. Well, there are always cultured or gendered ideas buried in definitions, and science is no exception. In one version of science, the life of the mind is feminine. Those who do science are in some ways leisured, cultured, and protected, and in some ways feminine. In another version of science, women and other members of the underclass work, wealthy men think. In this version, science is very masculine. Men do math and engineering and make weapons. They do big science. Well, I'm not arguing for anything essentialist. If anything, I would argue that leisure to think is a human right and that culture and society should be organized to protect it. And that being practical and or understanding principles doesn't really belong to any one gender. Rather, any person might relate more strongly to one approach, principles versus making it work, than another approach. Anyone could relate to one or the other at any particular time in their lives. Getting back to the same question again, what is work? What is the dividing line between technology and science? Well, the human goal of an easier life draws on both science and technology in ways that I think are pretty hard to divide. If you think about power, the sources of power till between the 1690s and the 1750s, the first industrial revolution, are really wind, water, wood, animals, and human muscles. And you might add to that animal and vegetable fat for light, and sun and soil for food, and maybe a few minerals being used for heat, charcoal and oil perhaps. But mostly the power is wind, water, wood, animals, and human muscles. The power for human life in part 2 in the second half of the Industrial Revolution becomes machines and water, steam, machines in coal or oil or gas, electricity, nuclear power, and battery power, the ability to hold those things. And I put battery power off to the side because people have been experimenting with batteries for quite a long time. Well, this is a picture on the left of a medieval horse plow, and you can see the plow itself has some innovations, and the horse collar, which is essential for making sure that animals can do more work than they could before without that horse collar. The horse collar improves the horse's ability to work tremendously. So let's go again. What is work? It's making water predictable, available, and productive. And we've already looked at aqueducts, irrigation, and flood control. And we haven't really looked at, but are something that's interesting and important for the advancement of, we'll say, civilization, science, and technology together, are water wheels. And that was available in the Roman time, available in medieval time. It's still something we think about today. How do we do hydroelectric power? Then making wind predictable, available, and productive. We can think of windmills, and that's a very early invention. But then there's sails and ship hulls and the compass and clocks. All of that kind of comes together when we're thinking about making travel predictable and travel safe. So the wind as a source of power for traveling requires other instruments to make it work. And we'll see that in this week's lecture and next week's lecture. How about making wood predictable, available, and productive? Well, that goes to forestry, and it also goes to deforestation. So there are a number of cultures that really denuded their whole areas of wood, also ruining the soil in the process. So thinking about how forestry is managed is something quite interesting. Some of the newer historical theories suggest that folks in the New World burned large areas of forest in order to make soil productive, and that is why when natives in the New World died through being interacting with the Europeans, that the forests grew back, and when the forests grew back, the entire climate of the world changed slightly to be colder, bringing about what's called the Little Ice Age between 1300 and 1800. So that's something that's still under discussion, but it's an interesting theory, and it suggests that making wood predictable, available, and productive is a much bigger deal than you might think. So making soil predictable, available, and productive, well, we've got the three-field rotation, which we didn't talk about, but is pretty important innovation for human life, for making food more available. The horse collar, which I just mentioned, the seed drill, which scatters seeds more regularly, machines and pesticides and breeding and genetics, which we will get to, but that's also part of science contributing to human life and also technology contributing to human well-being. Then again, we've got animals, predictable, available, and productive, and we talked about domestication briefly. We're not really going to talk about herding, but that's a thing that is done all the way through the period we're discussing. Breeding, genetics, and I'll add veterinary care. These are all things that are a combination of science and technology. And last but not least, food, making food predictable, available, and productive. Having an increase in grain yields, the number of seeds that come off of the head, new crops, which we will talk about when we talk about the Columbian Exchange. And then we might also think about storage of food, for instance, in beer. You can put calories into beer. In pickling, if you can't keep something because you don't have any way of keeping it cold, you can pickle it. And that's true for meat and vegetables. And of course, refrigeration, which is something that's important for today, but also an invention and a scientific invention. So again, science and technology combining in all of these areas to make human life more manageable. I think technology intersects with science, most particularly with machines. Through the design of machines and buildings, we kind of blur the lines between technology and science. We look for an elegant design or efficient design, and we need blueprints and math versus trial and error to figure out how to make a machine work. If you think about the basic motions of a machine, you can consider that a machine needs to lift things like maybe a stone to set it up for Stonehenge, or a machine needs to be able to cut things. Perhaps we need to cut wood and we need to design a machine that will cut wood for us. Crushing has been a machine-made effort for thousands of years as we do milling. So anytime you see a mill that creates flour, crushing has been the machine that has been important to build for that. Pounding for pounding out metal is also important. Another very ancient machine is weighing. So if you want to know, is this pure silver or pure gold, you can know what that size should weigh if it's gold or silver. So weighing and balancing are a kind of scientific tool for deciding if something is a pure metal or not. Another thing that takes great innovation are the way gears convey motion from one plane or one direction to another, and that is a special province of the Industrial Revolution that we will take a look at. And last but not least, I want to mention ticking. This is kind of a silly way to talk about motion, but ticking, as in a clock, the regulated motion, something that can be controlled, was extremely important for figuring out longitude, and it was something that didn't really get sorted out until the 17-somethings, I think the 50s. So this is a machine-made effort that is a pretty important one for science. And last but not least, of course, we have circuitry, looking at how information is conveyed and stored. Is that we have a marvelous National Museum of Industrial History right around the corner in Bethlehem. It's on the south side. It is closed at the moment, but you can take a virtual tour. And if you haven't done that, I recommend that you do that. There is the link at the bottom of the slide.